Hello everyone. Today we are going to talk about building smarter, faster agents. We all know the challenge. As an AI agent runs, its context, instructions, conversation history, and data grows continuously. This eventually slows down response times and increases your token costs. To solve this, the Agent Development Kit, ADK, offers two powerful features effectively summarized here. Context caching, which allows you to reuse static data instead of resending it every time. Context compaction, which automatically summarizes past interactions on the fly to keep your context window lean. Let's dive into the first strategy, managing that growing history with compaction. Let's look at context compaction. If you have an agent that relies on recency, like a coding agent where you fixed a bug 20 turns ago and don't need that raw data anymore, keeping the full history is inefficient. As you can see here, instead of feeding every single raw invocation into the model, we compact older interactions into summaries. The model then works off these summaries, plus the most recent raw invocations, saving you tokens without losing the narrative thread. To visualize this, let's look at a story agent. This agent writes chapters of a story interactively. Naturally, as the story progresses, the context grows massive with every new chapter. Passing this entire history back and forth becomes costly and slow. Here is what compaction looks like under the hood. If you look closely at the JSON, we've taken 7 full chapters and compacted them. Instead of 7 massive text blocks, you now see 2 concise summaries and just the last active invocation. Effectively, we've turned 7 chapters of noise into 2 summaries plus 1 chapter of signal. This drastically reduces the payload. Implementing this in the ADK is straightforward. Within your app configuration, you can set the events _compaction_config. You have 2 main knobs to tune here. Compaction interval, how frequently we summarize the history, for example, every 3 turns. Overlap size, how many invocations we look back to ensure we don't cut off context mid-thought. By default, we use the root agents model for summarizing, but this is fully customizable. You can inject your own prompt templates to tell the model specifically what details to retain during compaction. Compaction saves token space. Context caching saves cost and latency. There are 2 ways to handle this in Gemini. Implicit caching. This is automatic for models like Gemini 1.5 Pro, Flash. If the system detects repeated content, it caches it for you. Explicit caching. This is what we enable via the ADK. It gives you control over exactly what gets cached and for how long. Here is how you configure explicit caching. Inside your context cache config, you set the rules for when the cache refreshes. Cache intervals determines how often we refresh the cache. For instance, every 10 invocations. Time to live, how long the cache stays alive, for example, 30 minutes. Min tokens, the threshold required to trigger a cache creation. This helps you balance freshness with cost savings. Finally, to get the most out of caching, you need to understand prefix caching. Caching relies on the beginning of your prompt, the prefix, staying the same. The problem is that many agents inject dynamic data at the very start, like the current time or user location. This changes the prefix every time, breaking the cache. To solve this, we introduced the static instruction abstraction. Static instruction. You put your core persona and rules here. This block never changes, ensuring a high cache hit rate. Dynamic instruction. You append variable data, like time or state, after the static block. By separating these, you ensure the heavy lifting is cached, while still keeping your agent dynamic.